Hello and welcome to episode 6 of Agents of Tech, our brand new science and technology podcast. I'm your host, Stephen Horn.
And I'm Atria Godfrey.
Together we'll explore the cutting-edge technologies shaping our world today, from big data and quantum computing to AI and robotics. Agents of Tech delves into science and technology and the ways in which they can meet some of society's biggest challenges.
Each episode features in-depth interviews with leading experts in the field, discussing the latest developments and their potential to improve our lives. Today, we are in the historic heart of the American automotive industry, Detroit, Michigan. The city is host to WCX, the largest technical mobility event in the world, where the global mobility community comes together to exchange ideas and deal with the challenges of today.
And the challenges of today don't come bigger than the decarbonisation of the automotive industry. Our colleague Katie Brace spoke to Dr. Kelly Senecal about how the transport industry can achieve a low-carbon future.
Joining me now is Kelly Senecal. He is the owner and vice president of Convergent Science. So thanks so much for joining us today.
Thanks for having me.
So let's start off with some big questions. What do you see as the biggest challenge the industry faces in reaching mass adoption of low carbon vehicles in the future?
That's a great question. I think probably the biggest challenge is doing an honest assessment of what it means to be low carbon, right? So we tend to focus mostly on the tailpipe, but when you actually look at driving a vehicle holistically in these different vehicle types, you really have to do something like a life cycle analysis to look at the various effects of electricity and producing the car and things like that. So the biggest challenge may actually be, having a fair assessment of how much carbon these cars are actually producing.
So coming off of that, in the early auto designs, we saw a lot of diversification of the powertrain and the propulsion options. Do you foresee that diversification happening with this, or as they figure out kind of what the definition is?
Yeah, I think I definitely see the diversification, but I think it should be intentional because in certain areas in the world, even certain areas in the US, one particular vehicle technology, say an EV or like a hybrid, may make sense in different states or different countries. So I think that the diversification will be there, but I think it should be intentional diversification. Let's put the best solution, where it fits.
And of course, the consumers play a role in this. So
Right.
What are your thoughts about the consumer acceptance of this type of technology and the impact of EV moving forward?
That's a great question. I think, you have kind of two camps. You have the camp of folks that will accept anything just to drive an EV, and if it takes them a while to charge, they'll be okay with that, or at least, they'll live through it. And then you do have the people that they don't want less convenience than what they have now. So if they could charge the vehicle as fast as they could fill up a gas tank, they'd probably be fine. And if we had the infrastructure in place where you had a charger everywhere you have a gas pump, they'd probably be fine. But there's a lot in this country and in the world that they don't want to have to make those convenience sacrifices. I think that's a big challenge for EVs. I think eventually we'll get there with the technology, but right now it's a huge challenge.
So a lot of times people are owning their car for about 12 years now.
Yeah.
So that does give you some time, but what impact does that have on the EV market?
It's just as important to figure out what to do with the existing fleet than what we do with new vehicles. And so we really need to focus more on things like renewable fuels and alternative fuels, because we can use the current infrastructure to fuel the current fleet with net zero CO2 emissions. So I think that's a really important part of the entire kind of decarbonization plan, because those cars are going to be on the road for a long time.
And when you talk about the decarbonization plan, you do need to attract some of the best and brightest talent to the industry to work on this. How do you do that to help get society to net zero?
We want to keep the diversity in the powertrain options. We don't want to shut anybody out and say we're not doing combustion anymore, we're just doing EVs, because now you lose that talent that could be coming and helping you improve your combustion engines. So I think as long as we keep the message of a diverse portfolio of solutions, sustainable future, I think that's going to go a long way to attracting the best talent.
And are there other solutions to get to low carbon emissions besides EV, like pushing people toward ride sharing or another avenue?
Public transportation is a great approach. It doesn't work for everybody and it doesn't work everywhere, but when it works, I think we should take advantage of it. In cities, I think active transportation, active mobility, biking and things like that is a good option. But again, not everybody can do that or wants to do that. Possibly some hydrogen and also EVs kind of collectively, because just picking one of these and going full bore in that direction could lead to unintended consequences and could lead to problems in the future. So we need to kind of keep our options open.
A lot to think about.
Yeah, for sure.
All right, well, Kelly Senecal of Convergent Science, thank you so much for taking the time. We appreciate it.
Thank you.
Diverse solutions are key to achieving net zero, meaning cutting greenhouse gas emissions to as close to zero as possible.
And we return to the theme of diversity with our next guest, Dipti Vachani. She is a keynote speaker at WCX and an expert on another big issue at the Congress, software-defined vehicles. A software-defined vehicle is any vehicle that manages its operations, adds functionality, and enables new features primarily or entirely through software, therefore unlocking new possibilities by further integrating our vehicles with the digital world.
As Dipti Vachani tells our colleague Katie Brace, diversity is key in driving innovation and critical to the future of the industry.
Joining me now is Dipti Vachani. She is the Senior Vice President and General Manager of Automotive Line of Business for ARM. Welcome, thanks for joining us.
Thank you for having me.
So, the first big question for you is, what is the biggest impact that software-defined vehicles will have on mobility? We're gonna start with the big one.
Wow. So with the big question, we got to scale back a little bit and ask the big answer, right? At the end of the day, the two different challenges that the OEMs are struggling with is scalability. How do I get all of these features out into all of these cars and in a methodology which impacts hundreds of millions of vehicles on the ground? And number two, I talked about how R&D is going up for the vehicle, right? If you think about the 100 million lines of code, maybe 5 or 10x that for a fully autonomous vehicles. Translate that in your head to dollars, right? And the electronics of a car are going up. So the R&D of a car is going up. We need to find new business models because we've got to make ends meet at the end of the day. Making ends meet means new business models. Consumers, we know, are willing to pay. We're willing to pay for new features, new capabilities of the car. It's like Christmas Day. They get new features every time a software is released. So it's an opportunity for the OEMs to have a continuous engagement with the consumer, as well as have new business models, which is going to be necessary in this new world of costs going up.
So going off what you just said, what is the biggest or are the biggest challenges going forward for the automotive industry?
Well, the biggest challenges come in the fact that there's a culmination of multiple things, and they're actually all separate. We kind of think of them all, and most times people think of them, they all come together in their heads. Like, of course, the new autonomous car or the new autonomous features car is going to be electric. Those are two separate things. One's a powertrain problem, and then the other one's a central compute problem. And then add to that the third component, which is I want entertainment. I want it to entertain me. I want all these applications. I want movies to play, right? Things like that. That's the user experience. And so as all of this comes together in our minds when we talk about the overall totality of the experience of a car, from an OEM standpoint, these are three massive undertakings, massive grounds up development that has to happen. And having to deal with all of that coming together is a pretty complex environment.
So it sounds like innovation will really be key to SDV application. Why is diversity important in new innovation?
Oh gosh, this is something I'm extremely, extremely passionate about. The only way we make technology that's applicable to a diverse world, which we all know that it is to have diverse people making it. It's that simple. Who are they testing it on? What was their frame of reference? Those are the questions you ask. And then you have a diverse team creating it. It's innately going to consider diversity. So of course we want inclusion. Of course we want more women and diverse candidates in this industry because that expands our engineering pool. But more importantly than that, we need those folks that are diverse making this technology, or the technology will not work.
So that kind of brings me to my next question. Everything that you've just said and talked about prior, cars are complicated. They were complicated before. They're even more complicated now. Have there been any surprises for you in working in the automotive industry?
So I've been in this, I'm going to age myself a little bit here. I've been in this space for quite a long time. And I talked about the fact that my first technology in the automotive space is trying to move from analog amplifiers to digital amplifiers. And it was a fight to get the industry to embrace digital amplification instead of analog. And I know that sounds like, well, of course it's going to be digital, but it was hard to embrace. And I come back to the automotive industry, and at the speed is embracing new technology is unprecedented. It's unprecedented. Artificial intelligence, machine learning, deployment, continuous deployment, cloud to edge. All of these things are happening almost first in automotive before the rest of the world. If you want to work on the latest and greatest technology, automotive's the place to be. And it's cool to say that again.
Dipti, Vachani, thank you so much for taking the time.
Thank you for having me. Thank you.
Some very interesting insights there from Dipti about how the automotive industry is driving innovation in AI, machine learning, and cloud-based technologies.
Yes, now we hear from Richard Wagner, Director of Buildings and Transportation Science Division at Oak Ridge National Laboratory, Tennessee. Richard talks to our colleague Katie Brace about how we can transition to this high-tech and low-carbon future in the automotive industry, and the role of US national labs in developing technology and talent to do just this.
We're now joined with Robert Wagner. He is at Oak Ridge National Laboratory, where he is the Director of Buildings and Transportation Science Division. Welcome, Robert. Thanks for joining us.
Thank you.
So let's start off with, what do you think is the biggest challenge that faces the industry in really the mass adoption of low carbon vehicle?
I think it's just getting the technology out there, whether it's electrification or combination electrification, new fuels. It takes time. And how do we get it? How do we transition infrastructure, turnover of the fleet, all of those things?
And playing off time, history does have a way of repeating itself. And in the early auto design days, we went through a period of diversification in the powertrain and the propulsion options. Do you see that happening when it comes to the business climate for automotive and EV moving forward?
I think it has to, at least during the transition. I don't think we're going to flip a switch and have complete electrification overnight. It's an interesting idea, and technology is certainly going fast, so we'll see. But again, for a while, we're going to have a bit of everything. And some applications, I think, will always, but for a long time, need an engine, especially off-road mobility. So think of rail, marine, aviation's tricky for long distance. On-road commercial vehicles, I think we'll see how the fuel cells, engines, electrification all play out. So it requires a transition.
So do you think when a shift to more sustainable, low carbon mobility will require, development, demonstration, and we have a lot of the companies doing this, but what do you think the role of the national laboratories will be in this in the future?
No, that's a good question, because the national labs they're these interesting big science resources.
Right.
And for example, Oak Ridge National Laboratory is part of the Office of Science. So we have the world's fastest neutron source. We have the world's most fastest computer at the moment. Incredible material science, amazing history. And other labs have similar stories, so I don't want to make this about Oak Ridge, but there's these neat science tools that a lot of times the sort of foundational frontier type things we find can inspire technology solutions, and often could be equally some technology need, and we turn to the really fundamental science of solid materials is a big one. So I think that's the role they play. These are big facilities that can't be stewarded by anybody but the government.
So when you look at all this, what do you think the critical skills are for the scientists and engineers when you're looking at the future?
I think the big one, and this is something I've always loved about the labs, is working in multidisciplinary environments. So while I certainly have enjoyed a career where I had time to really focus on these fundamental specific problems, it was always with an eye on to how that fits into the bigger picture and trying to understand other disciplines. So I think the students coming up now, this phrase team science gets overused, but it's really important. And you need to understand the disciplines you need to interact with. There's this term I've been hearing recently, transdisciplinary, which basically means somebody is really deep. And say you're really deep in power electronics, but you're also a known expert in high performance computing. at the same time. So you have these sort of dual hats where you're very deep and can bring these areas together to solve these problems.
So when you look at all these disciplines and coming together, what do you think will be commonplace in transportation in just, say, a quarter of a century, 25 years from now?
That's another good question. And so I'll think more about some of the technologies, some of the things that have changed in my career, say 30 years since grad school, since undergrad, is things we were doing, like for my research, they thought, well, that's interesting academic curiosity, you'll never see that in production. But now with all the changes in sensors, actuators, data management, onboard computing, I think those things will continue to grow, become more affordable as they've had. I mean, we're running computers now that would have been considered supercomputers in the 90s. 25, 30 years from now, will quantum be at a state that we can use it even on board, or if not there, managing really complex systems of systems, if you will, regionally. And so I think we're going to see these things continue to happen. A lot of the technologies in 25 years, we don't even know what they are yet.
Very wise. All right. Thank you so much, Robert Wagner, for taking the time. We appreciate it.
Thank you.
Quantum technologies will be key for future intelligent, climate-friendly transportation systems, capable of detecting potential hazards around corners and equipped with independent, resilient navigation and secure communications.
Although quantum computing is still in its infancy, the potential of this emerging technology to change the world cannot be understated. Transport is just one of the many areas where the power of quantum computing has the potential to change everyday lives.
And here on Agents of Tech, we'll do our very best to keep abreast of this global race to develop the new quantum era.
Stephen, I think that will certainly keep us busy. All right, until next time, goodbye.
Goodbye.